13.8 billion years ago, there were no people, no planets, and not even space. Just a state of nothingness. Then a certain explosion occurred, and that's how the universe was born. Over countless ages, various stars, planets, Earth, and eventually humans came into existence. But something seems strange. Why did an explosion occur in a place where there was nothing? And in such a vast universe, why did a highly intelligent species like humans appear on a planet like Earth? Honestly, unless someone had orchestrated it, no one could explain this greatest mystery. This led some to propose a theory. What if the universe is nothing but a simulation created by highly advanced technology? Philosopher Nick Bostrom even conducted thought experiments to support this idea, and the simulation theory of the universe began to gain attention. Elon Musk, CEO of Tesla, SpaceX, and Neuralink, also said that this theory is quite plausible.
It would seem to follow that the odds that we're in base reality is 1 in billions.
Though Musk is known for making outlandish statements, he seems to be genuinely serious when discussing this topic. And after listening to his reasoning, it's not entirely incomprehensible. So could this universe, or rather the reality we live in, merely be a simulation created on someone's computer? Are we just NPCs in a highly advanced virtual reality? Today's topic from our corner of science: are we living in a simulation? Let's begin now. Just 40 years ago, a game called Super Mario Bros. Took the world by storm. It was a pixelated game with a CPU running at just 1.79 MHz and only 2 kilobytes of RAM. Yet it was enough to astonish the world. The addictive gameplay and the then rare cutting-edge portable computer made it something everyone wanted to own. Since then, the computer market has evolved through continuous advancements. In just 20 years, the computer industry achieved exponential growth. In 2002, Japan created the world's most powerful supercomputer, the Earth Simulator, which boasted a processing speed of 35.86 trillion operations per second, once again astonishing the world. The price of this top-tier supercomputer at the time was a staggering 60 billion yen, equivalent to about 1.8 trillion won in today's value, a substantial amount for such a high-tech piece of equipment. But just 20 years later, in 2020, computer enthusiasts could buy a graphics card like the RTX 3080, which also has a processing speed of 35 trillion operations per second. Now, you can enjoy the performance of a top supercomputer at only a fraction of the cost. To put things in perspective, the top supercomputers built up to around 1997 are far behind in performance compared to the smartphones you are holding today. In just 40 years, humanity has managed to experience the performance of supercomputers using far less money and electricity. And now, we live in an era where we can enjoy games that are more realistic than reality itself, like GTA and PUBG. In fact, computer performance has already surpassed these games. We've also entered a world of VR and the metaverse, where you can not only see but also directly experience virtual reality. So that's saying a lot. Science and technology have progressed to the point where they can create reality itself without us even realizing it. So what if we advance just a little more? Maybe in a few decades or even just a few years. Could we reach a level of technology that can replace reality? The simulation theory of the universe begins here. Some scientists propose that the universe might actually be a computer. They suggest that the reality we live in functions like a computer or a game. For example, when playing an open-world game like Minecraft, you might notice that objects far away appear blurry. While this may seem like an attempt to emulate the human experience of distant objects being unclear, it actually happens because of the limited computing power. The computer doesn't render objects that are far away in order to optimize processing power. Similarly, the parts of the game world that you aren't looking at don't exist in rendered form. They vanish because the computer hasn't calculated them yet. In other words, the computer only calculates and displays what you're looking at to maximize efficiency. Of course, it would be ideal if everything, near and far, could be rendered, but computer power is finite, so you can't just produce unlimited CPU and GPU performance. That's why researchers are still striving to show higher performance with less power, continually upgrading existing products. This brings us to the claim that the universe itself might be a computer simulation. The idea is that the universe, like any other system, is designed to handle things efficiently by setting limits. The renowned physicist Richard Feynman once said, "Everything is made of atoms. No matter what object we see, if we keep breaking it down, we eventually reach atoms, the smallest units." Of course, it's possible that this is the smallest unit we know of, because our current scientific technology isn't advanced enough to break things down further. But some interpret this differently. Our world has a minimum unit, called the Planck length. The Planck length is derived by combining constants related to the fundamental physical laws that make up our universe. It's the smallest meaningful length that can be measured and considered in our universe. Moving 0.99 Planck lengths is the same as not moving at all. And moving 1.99 Planck lengths is the same as moving 1 Planck length. In other words, any value smaller than 1.0 Planck lengths is meaningless. This concept seems similar to something we've seen before, like the smallest unit of data, a bit, or the smallest unit of graphics, a pixel. Additionally, the speed of light, according to Einstein's special theory of relativity, is fixed at 299,792,458 kilometers per second. It remains constant whether in a vacuum or through air. Some suggest that this is a constraint set to prevent infinite computation, similar to the limits imposed on a computer's calculations. Some scientists even claim that the universe is expanding because not all the calculations have been completed yet. In any case, these proposals lead to the idea that our universe itself might be a computer operating with various limits to maintain efficiency. In fact, our universe is continually optimized to process vast amounts of information. This concept can be illustrated by the famous double-slit experiment. The double-slit experiment was conducted in quantum mechanics to determine whether light behaves as a wave or a particle. It involved shining light through two tiny slits and observing how the light's trajectory was recorded. If light is a particle, it should pass through one of the two slits, leaving only two trajectories. If it's a wave, it should create an interference pattern. However, before a camera was installed, the light behaved as if it hadn't fully rendered yet, creating a blurry interference pattern. But when a camera was installed, it left only two clear trajectories, just like the world we observe. In other words, electrons exist as particles when observed and as waves when not observed. This is similar to how computer games render things clearly when you're looking at them but only exist as calculations when you're not. If we stretch this idea, it suggests that if no one on Earth is looking at the sun ceases to exist. But if someone looks at the sun, the universe's vast computer calculates and renders it into existence. Our world might be operating efficiently like this, trying to conserve computer memory. At first glance, this seems quite plausible, but these claims are issues we cannot definitively prove. Even if everyone in the world agreed not to look at the sun, we still wouldn't know whether the sun existed or not at that moment. The moment someone tries to observe it with a camera, the universe's vast computer would have calculated and rendered it. And the problem doesn't end here. Scientists have calculated the mass of the universe, which is a staggering 1054 kilograms, equivalent to about 50 Earths, with 28 more zeros added. Even if the universe's computer is optimized, simulating such a universe would require an unimaginable amount of computation. To do this, the universe would need to be an ultra-super-mega computer of incomprehensible performance. And without building a computer of such capabilities and testing it ourselves, we cannot prove that this is true. Then a philosopher decided to explore this argument from a more realistic perspective. In 2003, philosopher Nick Bostrom published a provocative paper titled, "Are You Living in a Computer Simulation?" His argument starts with the following thoughts. First, if humanity advances sufficiently, it will eventually be able to simulate the entire universe on a computer. Second, once that level of advancement is achieved, there will be no reason to run just one simulation. Many universe simulations would be running simultaneously. Third, the civilizations within these simulated universes could themselves develop to the point of simulating their own universes. If this cycle repeats, simulated universes could become countless. Finally, how can we be sure that the universe we live in isn't one of these simulated universes created by a previous advanced civilization? According to his argument, if humanity reaches a level of development that allows us to simulate a universe, we would likely create dozens, hundreds, or even more universes. So how can we be sure we aren't living in one of those simulations? Bostrom's simulation hypothesis leads to the following conclusions. First, humanity is highly likely to become extinct before reaching the level of technology needed to simulate consciousness. Second, even if humanity achieves such a level of technology, the likelihood of running large-scale simulations that reproduce consciousness is extremely low. Finally, we are already living in a simulation. Let's examine these conclusions one by one. The first conclusion, that humanity is highly likely to become extinct before reaching the level of technology needed to simulate consciousness, contradicts Bostrom's initial premise that humanity could eventually simulate the entire universe. The argument began with the assumption that such technology is achievable, so this possibility can be considered low. Next, the second conclusion. If humanity surpasses the first hurdle and reaches a level of science and technology capable of creating simulations, it seems likely that humanity would have an interest in simulating past events or history, so there would be no reason not to conduct simulations. That leaves the final conclusion. We are already living in a simulator. This is why Nick Bostrom argues that we are living in a simulation. And if we assume there are about 1 billion such universes, the probability that we are not living in a simulated world is just 1 in a billion. This is why Elon Musk also claims that the probability of our universe being real is only 1 in a billion. Moreover, Silas Bean, a quantum biophysicist and researcher in quantum simulation at the University of Washington, published a paper discussing the constraints of the universe as a simulation based on numbers. Simply put, the paper explores methods for detecting whether our world is indeed a computer simulation. It suggests setting the 4 fundamental forces discovered in the universe into a computer simulation and then comparing the results. Observations from these simulations revealed slight, inexplicable anomalies, strange phenomena that cannot be explained for some unknown reason. If these simulations are correct and similar anomalies are found in the real universe, then we may indeed be living in a simulated universe. The problem is that we have yet to find such anomalies in reality. In fact, the theory of a simulated universe is not entirely new, around 380 billion. See, the ancient Greek philosopher Plato, a student of Socrates and the teacher of Aristotle, wrote in his work, The Republic, about a story in which prisoners, chained in a dark cave, could only see shadows cast by a fire behind them. The prisoners mistake these shadows for reality, as they cannot see the actual objects creating them. While this allegory isn't the origin of the simulated universe theory, it raises a similar question to the one posed by the theory: what is the true nature of the reality we see? And now, through the theory of a simulated universe, we are searching for answers to this question. Although we haven't found any concrete evidence yet, and it remains a speculative story closer to science fiction, it continues to spark our curiosity. In the movie The Matrix, the protagonist Neo asks, "Is this real?" To which Morpheus, who awakens him, replies, "What is real? How do you define real? Reality is just electrical signals interpreted by your brain." French philosopher and scientist René Descartes famously said, "I think, therefore I am." This has been CPW Science.